All right, we're going to go back to section A5 and talk about another method of solving equations. So the learning target today is to be able to solve rational equations. And we've talked about what a rational number is. So that is any number that can be written as a fraction where the numerator and denominator are both integers. And when we're talking about rational equations, we're talking about the rational numbers that have polynomials in them. Okay? So please add that to your learning targets sheet. All right, so you don't have to write this down, but I just want you to kind of take a look at where we've been and where we're going. So this is what we did before. We had something that maybe looked like this: 3 over x minus 1 minus x minus 4 over x squared minus 2x plus 1. Okay? In this case, we were simplifying this expression. I had to take one rational expression and subtract another rational expression and then just simplify. This is what we're going to be doing now. Okay, so I have one rational expression equals two rational expressions being added together. And in this case, we're going to solve. Okay? So simplify versus solving. What's the difference? How do we know, and this is something that you're really going to have to think about, how do we know the difference between simplifying and solving? So the difference between the top expression and the bottom is the equal sign. Okay? In an equation that we're trying to solve, we have an equal sign, which means we're trying to solve for x to see when the two sides are equal. So the difference is my expression does not have an equal sign. So when I simplify it, my answer is a fraction. Okay, now this is really important to remember. When I have no equal sign and I just have two expressions that I'm trying to subtract or add or multiply or divide, and there's no equal sign, my answer will be a fraction. Now in this case, I'm trying to solve for x. Solving means I'm trying to find a value for x, okay, that will make these equations equal. So my answer is a value for x. So it will look like x equals blank. Okay. So you really have to make sure that you know the difference. It's very important because when you see two expressions with no equal sign versus one with the equal sign, there's going to be a very different process. Okay, so we talked about the process before. Up here, simplifying, we need to find a common denominator, and my answer will still be a fraction. I cannot get rid of my denominators. When we're solving, it's going to be a much different process. Okay, so let's recall how to solve this equation. So this is just a simple rational equation here that you may have seen before. Okay, maybe probably in Algebra 1 might be the first time you would see something that looks like this. And when we're trying to solve this, instead of trying to find common denominators to add the two sides together, which is something that we could do, and in this case, it would be pretty easy to do. We know an easy common denominator between 2 and 3. But instead, because we're going to get to more complicated problems, as you know, with polynomials, and so we kind of want to find an easier way to go about this. So what we want to try and do is clear the denominator. Okay, so we want to try and multiply by a number on both sides that will cancel out all three of those numbers. So I'm looking for the least common multiple between all three of those numbers, 2, 3, and 6. So a multiple of 2, a multiple of 3, and a multiple of 6 that they all share. So in that case, that's going to be 6. Okay, 2 times 3 is 6, 3 times 2 is 6, and 6 times 1 is 6. So I'm going to multiply both sides of this equation times 6. Okay. So that means everything on the left side is multiplied by 6. I have to distribute that 6. Okay? So I get 6x over 2 plus 6 over 3 equals 6 times 5x over 6. So by doing this, it cancels out these denominators, because now I can take 6 divided by 2, which is 3. 6 divided by 3 is 2. These cancel out, and we get 5x. So now I have created an equation with no denominators that I can easily solve. So subtract 3x from both sides, divide by 2, and x equals 1. Okay. But of course, we always need to check, or we want to check, to make sure that this answer works. Okay, so let's check our answer. So I'm going to plug 1 back in for x to make sure that the two sides are equal when x is equal to 1. Okay, and this is a great habit to get into to make sure that you've done this right. So I need a common denominator to add those fractions. So 3 6 plus 2 6, does that equal 5 6? Whoops, not 56. Okay, so 3 6 plus 2 6 is 5 6. That equals 5 6. So we did that right. So my answer, x equals 1. Okay, so we're going to take that same method and apply it to polynomial rational equations. So before we do that, let me go ahead and write down the steps, okay, to have in a good place in your notes. In case you forget, it'll be a good reference to have. So first step, make sure all the denominators are factored completely. We did the same thing when we were simplifying, because that's an easy way to find the least common multiple, to see what factors that the denominators have in common. Determine the least common multiple of the denominators. Okay, so it starts out the same as simplifying. So simplifying and solving have the same first two steps. But in solving, you're going to multiply both sides by the least common multiple and cancel things out. Whereas we can't do that when there is an expression, because we don't have two sides of an equation. Okay, so with an expression, there's no equal sign, so there's not another side that I can multiply by to keep them equal. So this is where it becomes different for solving. Step 4, solve the new polynomial equation using appropriate methods. Okay, so that means once we clear the denominators, if I have a linear equation, solve it the way you know how. If I have a quadratic, okay, you could solve it by completing the square or factoring. So any way that you know how to solve the resulting polynomial, that's how you need to solve it. And then check for any extraneous solutions. Okay, so it's possible that there might be solutions that won't work. For example, if anything makes the denominator 0, then that's going to be extraneous, and we can't use that solution. So we always have to check to make sure that our fractions are not being divided by 0. All right, so let's go ahead and try an example where we're solving a polynomial equation, a rational equation where we have polynomials in the denominator. Okay, so we have 3 over x minus 2 is equal to 1 over x minus 1 plus 7 over x minus 1 times x minus 2. So I need to find the least common multiple and multiply this. So what that means is whatever I multiply by, because I have to multiply by the same thing on both sides, whatever I multiply by has to cancel out all 3 denominators. Okay. So in order to cancel out my denominator here on the left, I need to multiply by an x minus 2. In order to cancel out my second denominator, I need an x minus 1. And then to cancel out my third denominator, I need both of those things again. So I can multiply by x minus 2, x minus 1, and that will take care of both denominators. Okay, so multiply by x minus 2, x minus 1. Now remember, I need to distribute here. So everything in the equation is being multiplied by that least common multiple. So I have 3 times x minus 2, x minus 1 over x minus 2 equals x minus 2 times x minus 1 over x minus 1 plus 7 times x minus 2, x minus 1 over x minus 1, x minus 2. So I multiplied by these because the point of multiplying by them was to cancel out any in our denominators. So when you're solving an equation, you want to clear the denominator. So I have 3x minus 3 equals x minus 2 plus 7. So this is a linear equation. So now we just solve the way we know how. Combine like terms, subtract x from both sides, add 3, and divide by 2. So I get x is equal to 4. So I need to check to make sure A, this is not extraneous, and B, that I actually got the correct answer. Okay, so not only are you checking for extraneous solutions, but you're also checking to make sure that your answer is correct. Okay, so we know that 4 won't make any of these denominators 0. So let's go ahead and plug it back in to make sure that this works. So we have 3 over 4 minus 2 equals 1 over 4 minus 1, 7 over 4 minus 1, and 4 minus 2. Simplify that. 3 halves equals 1/3 plus 7 over 6. We need a common denominator to add that together on the right side. So I get 2 6 plus 7 sixths. Okay, we're asking, do these equal each other? Does 3 halves equal 9 sixths? Yes, because I can simplify 9 sixths to 3 halves. So my answer, x equals 4. Doesn't make my denominator 0, and when I plug it back in, makes the equation true. Okay. All right, let's do one last example where we have an equation that is a little bit more tricky, where we have to follow all the steps. So 5 over 3x minus 1 is equal to negative 2 over 3x squared plus 5x minus 2. Okay. So our first step that we wrote down in our steps was to factor the denominator of all of our rational numbers. Okay. So what I'm going to ask you to do when you're showing work for this, please over to the side do your factoring. Okay, it's going to make it a little bit easier than trying to keep that in that equation. Don't just do it, don't just work underneath here and then all of a sudden put your equation, the rest of your equation under that, okay? Remember, when we're working down like this, we need to have each of our steps equal to the step above it. So off to the side, let's go ahead and factor this polynomial, 3x squared plus 5x minus 2. So 3 times negative 2 is negative 6, and two numbers that multiply to give me a negative 6 and add to give me 5 are 6 and negative 1. Factor by grouping, 3x squared plus 6x plus negative x minus 2 are my two groups. And then I get, factor out a 3x to get x plus 2 left. Factor out a negative 1, and I get x plus 2. So I have x plus 2 times 3x minus 1 is what that factors to. So we have 5 over 3x minus 1 x plus 2, 3x minus 1. Okay. All right, so I need to find the least common multiple. So now that I factor this, I can see what factors these two rational expressions have in common, the two sides of the equation. So I need to multiply by a 3x minus 1 for both of these to cancel that out. And I also have to have an x plus 2 in there. To cancel it out. And both sides need to be multiplied by the same thing. X plus 2, 3x minus 1. So that would be 5 times x plus 2, 3x minus 1 over 3x minus 1. Multiplying both sides. Okay, so I just multiplied both sides by that least common multiple. I can cancel out 3x minus 1 here. X plus 2, 3x minus 1 here can cancel out. So I'm left with 5x plus 10 equals negative 2. Subtract 10 from both sides. Divide by 5. And I get x is equal to negative 12 over 5. Okay. So we want to go ahead and check this for extraneous solutions to make sure it, A, doesn't make our denominator 0, and B, that we actually found the correct answer. So I can already see by looking at my denominators that if I plug in negative 12 fifths to x, I'm not going to get 0 in my denominator. So I know that it's not going to be extraneous. But I need to make sure still that it's the correct answer. So let's go ahead and check this. So I'm going to plug negative 12 fifths back in for x. And we've got some simplifying to do. So we'll simplify all the denominators first. Okay, we've got a lot of crazy stuff going in the denominator, so we want to simplify that down to one number. So I have 5 over negative 36 fifths. Okay, so just multiply across, minus, we'll change that to a common denominator because we know we need to subtract that. And I have negative 2 over 3 times 144 over 5 plus, let's do minus 60 over 5 minus 2. 5 over negative 41 fifths is equal to negative 2 over Okay, I made a little mistake up here. This squared, negative 12 fifths squared, should be 144 over 25. So this is going to be 432 over 25, okay, because I needed to square this negative 12 fifths. Square both the top and the bottom. 432 over 25 minus 60 over 5 minus 2. So on that right side, we need to find a common denominator. Okay, so I'm just simplifying, so I'm keeping the numerator the same and just going through and simplifying the denominator with my fractions. Okay, so we got 432 over 25 and 60 over 5 and 2. So let's find a common denominator for that. So we still got my 5 over negative 41 fifths over here. Okay, kind of ignoring the numerator for now, and I got 432 over 25 minus 300 over 25 minus minus 50 over 25. Well, that's going to give me 432 minus 300 minus 50 is 82 over 5. So now I'm dividing fractions. Now, since I've simplified the numerator, I have 5 over negative 41 fifths and negative 2 over 82 fifths. Divide fractions, you multiply by the reciprocal. So copy the first fraction, multiply by the reciprocal of the second fraction. Copy the first fraction, multiply by the reciprocal of the second fraction. Okay, and again, we're trying to figure out, are these equal to each other? So negative 25 over 41, does that equal negative 50 over 82? Simplify negative 50 over 82, and you get negative 25 over 41. Okay. So that works, plugged it in, it makes my equation true, which means my answer truly is x is equal to negative 12 fifths. Okay. So make sure you're checking your answers. Sometimes you will have answers that will be extraneous, and also you want to make sure that you did your work right. So plug that back in to check your answer. All right. So go ahead and after doing those 3 problems together, you have 3 practice problems to do before coming to class next time. So 42, 78, and 80, do those in your notes on page 998, and then we will talk about those in your groups, but I will check those off when you come to class next time.